for digital technology, we will be studying that information is stored in a series of switches, basically, okay? In a series of yeses and nos, and in the most easy way to conceive of this, in a series of ones and zeros, all right? So really quickly, let me just explain to you something here. Right here on the screen you see 27, or excuse me, I think, yes, 27 little blue squares, okay? Now, the fact that I can represent this number, like this, 27, what we have here, all right, are a number of a certain amount of things here, okay? This is just a number, okay? Here we have numerals, all right, that represent what that number is. And these numerals have meaning to us because, well, we've lived our whole lives dealing with things being counted in sets of 10, really, is what it comes down to. We have 10 fingers, which is a number system that we call decimal. So let's get started with that really quickly. So for decimal numbers, these are numbers that we express using base 10. What does base 10 mean? Well, any number can be represented as a series, as a sum of powers of 10s, okay? So in other words, that number 27 that I had there before, it can be represented as 2 times 10 to the first plus 7 times 10 to the 0, okay? So what that shows us is that we have some single integer value, all right, that we're multiplying times a power of 10, and that single integer value is anywhere between 0 and 9. So we can also express numbers of things differently. It doesn't have to be in a base of 10. In other words, going up from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we restart in the next place, 1, okay, and then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, obviously 10, 11, 12, 13, 14, 15, all up through 19, and then reset that next 10 to 2, and so on, okay? We can do this as well with binary numbers, which are numbers, all right, expressed using base 2. In other words, if you look at the little chart that you have there, the numbers go from 0 to 1, then we reset in the next place with a 1 and 0, then 1, 1, then reset in the next place, 1, 0, 0, 1, 0, 1, and that's how we count up, okay? Never going to 2, just like in base 10, you never go to 10 actually, that's just like the limit of what you're counting to, all right? So, when we deal with digital information, okay, all information is broken down into numbers in binary, which are 1 or 0. And we call either of these a bit, which is just one unit of binary information. Okay? So the issue is converting the binary number 101, an example here would be to convert the binary number 101 to decimal to show you guys exactly what's happening here, right? So before I was telling you that everything can be, in decimal can be represented as a power of 10, here in binary everything can be represented as a power of 2. So in other words, okay, we have 3 places here. This is, in this place this is 2 to the second, this place this is 2 to the first, in this place this is 2, all right, to the 0th, all right? So if we're going to convert this binary number to decimal, what we do is we just take 101, all right, and it's going to be 1 times 2 to the second plus 0 times 2 to the first, since there's a 0 there, all right, plus 1 times 2 to the 0. And what we end up with here is 5. And if you look at your table there, that is exactly what you get when you count in binary all the way up to 1, 0, 1. Okay? So if we come over here, okay, and we look at this, all right, we see that we have 5 little squares here, all right, and we're going to end up converting this, okay, into base 2. And what this basically is, all right, this is 2 to the 0, all right, 2 to the 1, and 2 to the 4. And we break it down like this, basically, okay, into these groups as we go along. So 2 to the 2, this is 4. So let me show you an example of that, though, from the previous one. So with 27, I told you that there's 27 little boxes here, right? the idea here is we can rearrange this, okay, into tens and ones. In other words, this is 10 to the 1, and this is 10 to the 0. And how many 10 to the 1s do we have? Well, we have 2, all right? And how many 10 to the 0s we have? We have 7, okay? So we can rearrange this here, all right? It's 10 to the 1 and 10 to the 0. So we have 2 here times this, and here this is 7 times this. And actually, you know what? It would be better if we rearranged it like this, so that it was more uniform to what we're doing here. So there we go. And I think that makes a bit more sense there. Okay, so there's 7 of these 10 to the 1s and 2 of these 10 to the, excuse me, 7 of these 10 to the 0s and 2 of these 10 to the 1s. And that's what gives us 27, all right? So for 5, if we organize 5 in binary, okay, the best way to do this, all right, is to have the biggest amount first. Okay, so 4, which is 2 to the 2, and we have 1 set of those, 0 sets of 2 to the 1, and 1 set of 2 to the 0, excuse me. Okay, so another example here is convert the number 10011 to decimal. All right, if we do this, okay, it's going to be equal to 1 times 2 to the 4th. All right, that's, this place is 2 to the 4th. Excuse me, this place right here is 2 to the 4th. This place is 2 to the 3rd, and so on. Okay, so plus 1 times 2 to the 3rd, plus see here, so it would be 0 times 2 to the 3rd. What's that there? There we go. Times 0 times 10 to the 2nd, plus 1 times 2 to the 1st, plus 1 times 2 to the 0th, and we end up with 16 plus 0 plus 0 plus 2 plus 1 equals 19. Okay? So right there, another example, we have 19 squares here if you count them up. And if we rearrange these here, okay, the biggest one that we can have would be 16. Then what's remaining is 3 after that. And group that into one group of 2, all right, for that one and 1 over here, okay? So we can only group these. Don't forget here, you can only count the total number of these sets as there are in your base. So what am I saying here? Okay, I can only count, you know, 10 single ones before, 10 single ones before or excuse me, 9 single ones before I go up to 10, okay? Same thing over here, okay? From we have 5, I can only count 1 single set of each of these places before I go to the next one because my base is 2, all right? So over here I can only count 1 set of these. There's zeros over here, so this is for the 8, this is for the 4, so it's 1, 0, 0, 1, 1, okay? Yeah, so that's the idea there, okay? Let's try another example. So convert the decimal number 27 to binary, all right? A good way to think of this is just to do 27, okay, minus 1 times 2 to the 4th, which will be 27 minus 16, that gives us 11. And let's see here. Once we have 11, you can subtract 8 from that, so 1 times 2 to the 3rd here, okay, gives us 8, excuse me, 3. And then the next one to check, right, is 2 to the 2nd. The unfortunate thing is you get a negative number here, so we can't subtract that. So what we end up with is just 0 in that place, okay? And then we do the same thing, 3 minus, let's see, 1 times 2 to the 1st here, and that works out okay, and that will give us 1. And then the final one here is going to be 1 minus 1 times 2 to the 0, and that'll finally give us 0. So we take all of these that we just solved for, this one here, this one here, this 0 here, this one here, and this one here, and you get 1, 1, 0, 1, 1. So the pattern, all right, for this one, what you want to do is you want to just keep subtracting. We go from 27 here. Again, we have 16, 8, 4, 2, 1. Okay? The idea is to keep subtracting powers of 2, all right? And as long as you don't have a negative value, it'll work out for you. You can use that place. You can give that place a value of 1. If it does give you a negative value, you have to give that place a value of 0 because you can't use that value. And subtracting it. Okay, it's not part of that number. So, all right, that's just the basics for converting between digital and, binary and decimal. The least significant bit is the last digit, and the most significant bit is the first digit, the first non-zero digit, excuse me. Okay, so we'll do some practice converting this in class, all right? Here, if we take a look at an example here, in the following number, let's see, we have 0, 1, 1, 1, 0. This is the MSB, the most significant bit, and this would be the least significant bit. All right? Okay, so again, this is just a manner of counting. It's just a different system in which we count. It's a different representation, it's a different numeral that we're using, but the amount is still the same, okay? That hasn't changed, it's just the way of counting. It's really strange because you've been counting in base 10 your entire life, but the reason is that computers can only understand yes or no, or on or off, basically, okay? That's the only thing that we can really communicate there. So that's it for decimal to binary, and the next video we're going to talk about is going to be concerned with digital technology.